Hello there again, this is Professor Roldan with Topics in Mathematics. This video is on 11.4, worksheet number 5, tree diagrams. Okay, so we have already discussed 11.1, and now we're going to be in 11.4. Okay, this is worksheet number 5. So this has to do with creating or constructing a tree diagram to be able to see basically the number of possible outcomes from a particular experiment. So I just want to go ahead and define or explain, I guess, tree diagrams. Just what's the gist of that? So why are we doing tree diagrams? That's to help determine, tree diagrams help determine the number of possible outcomes in an experiment. Okay? So in this case, we have two balls that are selected with replacement from a bag that contains one red, one blue, one green, and one orange ball. Okay? And so notice it does say replacement. So that right there means that so we have two events, okay? Two balls, two events right there. So that means we're going to grab from the bag twice. But on the second grab, we're going to be selecting from the full set of balls because we're going to replace the first grab. We're going to go ahead and put it back into the bag. So that's what this means here with replacement. Okay, I'll explain that in a little bit. So 4 colors, okay, red, blue, green, and orange. Now, construct a tree diagram and list the sample space. So, let's see here. So let's put this in the middle. So we have a bag that has 4 colors, and I don't have those colors, so I'm just gonna, they're all gonna be black in here. So we have a red ball, blue ball, green, and orange. Okay? And so from that bag, the first event or the first grab, so let's do, the first one could be red, and up here they're going to be called possible outcomes for the first ball, the first grab, okay? We could also have a blue ball picked. We can also have a green ball, and we could also have just a minute, an orange ball. Okay, so those are the possible outcomes for the first grab. So there's 4 different outcomes, and then when we replace that ball back into the bag and we pick again, when we pick again, we have 4 options once more. So now we have So possible outcomes for second ball, or the second grab, the second event. So we could grab a red ball once more, or we could grab a blue ball. We could grab a green ball, or we can grab an orange ball. Okay. And then, so that's after picking a red ball for the first event. For the blue ball, after picking the blue ball, we put it back, and we can also pick a red ball, blue ball, green ball. So all 4 options show up again, okay? And they show up for each of the second events here. And this is because we replaced, we replaced the first ball back into the bag. Okay, so red, blue, green, orange, red, blue, green, orange. So this is what we mean by a tree diagram. Looks like a tree. Okay, they branched out. Now, from these we can create our sample space. So we're going to make another column for sample space over here. So if you notice the first option right here, the first sample here would be if I picked a red ball and then I picked another red ball. So that's a possible outcome. So I'm going to put RR for red, red. I could pick the red ball and then the blue ball. Red ball, then the green ball. Red ball, then the orange ball. Okay, so that's four outcomes right there. And then we go down further. Blue, red. Blue, blue. Blue, green. Blue, orange. Okay. Green, red. Green, blue. Green, green. Green, orange. I'm just writing my outcomes. Okay, so the last one will be orange first. Okay, orange first in each case. The second ball, the first one's red, blue, green, and orange, orange. Okay. So now we can talk about how many total sample spaces are there. So if you count this up, as you can see, guys, there are 4 groups of 4. So that's basically 16 if you count those. Okay, 16 total. 16 total possible outcomes. Now, there's actually a shortcut to knowing how many possible outcomes. And that is called the counting principle, okay? So there is no shortcut for a tree diagram, but there is a shortcut for knowing the number that we get here at the end, and that is the counting principle. And it basically goes like this. If you have let's say 2 events, and you have M distinct ways, okay, of getting that events. So red, blue, green, orange, that's 4 events, or 4 outcomes for that first event. 4 distinct ways for the first grab. And then you have another amounts of distinct ways, n. So basically, you have m times n. So in other words, in our case, we had 4 colors or 4 balls. In the first option, we have 4 in the second, and so so 4 times 4 is 16. Okay? And that's how you can know the number. So we have 4 in the first event, and then 4 possible options in the second event. So 4 times 4 is 16. Okay, so I would like to go over these now, and we'll do some extra ones in class. So let's start with number 2. It says determine the probability that exactly 1 ball is selected. I'm sorry, 1 red ball. So exactly 1 red ball. So as long as we can find an outcome in our sample space that has 1 red ball, then he's part of our count here. So there is a red ball. I'm going to start at the bottom. There's a red ball there, there's a red ball there, there's a red ball there, and then there's a red ball here, here, and here. But we cannot use this one because that has 2 red balls. And the requirement was exactly 1. All right, and that is actually exactly 2, or at least 1. So we cannot use the outcome that has 2 red balls. So that's 1, 2, 3, 4, 5, 6. So I'm just going to go ahead and write them down over here. So we had red, blue, red, green, red, orange. We had blue, red, green, red, and orange, red. Okay, that's 1, 2, 3, 4, 5, 6. So the probability is the amount favorable, 6, over the total, 6 out of 16, and that can be reduced. Okay. If you reduce the fraction by 2, that's going to give us 3/8. Okay. All right, let's take a look at the probability of at least 1 red ball. So at least 1 red ball, we have the list over here up above in number 1. Okay, but now, since it says at least, and it doesn't say exactly, now, so we can now add the red outcome to our list from above. I'm talking about number 2 here. So if we had 6 in number 2 that we just did, and we add the red, that means we're going to have 7. 7 over 16, and that cannot be reduced, so we are done. Okay? So now I want you to do some of these in class. and I will tell you which probabilities to calculate. Okay, so now we have number 4, and we're going to do the same tree diagram, except this is called without replacement. So what's happening here is that we are not going to replace the ball that was chosen. We're not going to replace it back into the bag. And so that means we're going to have less options on the second grab. Instead of 4 balls to choose from on the second grab, we're going to only have 3 because we're not replacing it. So I would ask you to do this in class, but since you already have the answer key already there, I just want to be able to explain it. So here we go. So here's our bag, and then we can go ahead and say, okay, I can pick a red, I can pick a blue, I can pick a green, and I can pick an orange. So that's the first event. Now, remember, we're not replacing it. So once the red ball is chosen, there is no red. And so now I can only choose between the other 3, which is blue, green, and orange. And then if I take out the blue, I'm only left with red, green, and orange. And if I have the green gone, then I have red, blue, and orange. And the orange is gone, then I just have red, blue, and green. So there's our tree diagram. So our sample space would then be red, blue, red, green, red, orange, blue, red, blue, green, blue, orange. Actually, let's do our total sample space prediction. So remember, it's m times n. So the first grab has 4 options. The second grab, since we're not replacing it, has only 3 options. 3 colors to choose from. So this is going to give us 12 total, and we're going to prove it right here. So we have 3 from this group, 3 here. We're going to have green, red, green, blue, green, orange, orange, red, orange, blue, orange, green. And as you can see, guys, 4 times 3 is 12. So we have four groups of 3, which is 12 total. Okay, so this works. All right, so determine the probability a blue ball and a red ball will be chosen. So a blue ball and a red ball. So that means I could have a BR or an RB. Okay, and that happens, let's see, there and there. That's 2. So this is going to be 2 out of the 12, and then you can reduce it by dividing by 2. Okay. Determine the probability that a blue ball and then a red ball will be chosen. Okay. So this is very specific. It's blue and then red in that order. So our only option then would be blue, BR. Blue and then red. That's the particular order that's being asked for. So unfortunately, there's only one out of the 12, and that is done. So a probability that no green balls will be chosen. No green balls will be chosen. So we gotta take a look at our list here and write down our sample space with no green balls. So we have RB. RG has a green ball, so we skip that one. RO, or red orange, and then we have blue red, skip blue green, blue orange, and then we skip the whole green section: green red, green blue, green orange, and then we're going to go to the last section: orange red and orange blue. So that's 1, 2, 3, 4, 5, 6. 6 out of 12, and this reduces to 1/2. Okay, so that's basically it for 11.4. Now you try some, and then I'll have you create your own tree with a different scenario. All right, see you guys in the next video.